is pretty easy also, I'd say. So the goal here is to find the middle of linked list. So given a linked list, the goal is to return the middle node. That's simple. So let's try to come up with solutions. So what we see here is to get the middle, we first need to iterate through it, right, and return the middle index. One also requirement here is that you should return, if in case you have two middles, you should just return the upper one or the second middle. Yeah. So if you do an average, just get the index. If you do an average, get the ceiling. Let's put it that way. So what we have here is that we have this linked list as an input. What we will do, how I'll think about it, is that I will iterate through it, try to get the size of it. Then I will divide that by 2. And then I would iterate again to try to reach that node at index 2 or the middle index, and then give that as an output. So if you write steps in basic English, it's first find the length of the original linked list, 2 get the middle, and 3 navigate until reaching the middle index, and then we return. One thing also we should keep in mind, since we get here in the signature the head as an input, is that we need to make a copy of it, because if you did not make a copy and you want to just use it to iterate through until you get the length, you would lose the head, because at every step you do head is equal to head to next. So that's why I make a copy, so I can iterate and reach step 3. So let's go through the code. What I have here is first I make a copy of the head that I get. I have a variable to store the size, it starts at 0. I have the middle index, which starts at 0. And I have a counter that I would use for step 3. First step, as we said, we just iterate on the head until we get the size. Now we have the size. Then the goal is to get the middle index. We do that by just dividing by 2. And then lastly, we iterate on the copied one until we reach that middle index, or until we reach that middle index. Once we reach it, the loop will break and then it would return that copy. If we take a time to analyze, so the time complexity here, we can see here that we iterate here through the whole thing. So this is O of n, and here we iterate until the middle. So this is O of n over 2. So we can just round it up to be O of n. That's the time complexity, make it O of n. Space complexity is a bit tricky here. So space is O of 1 here, O of 1 here. The only thing that we should worry about is this one when we copy ahead. So I said it's O of n in case that we assume that the copy is, you have to go through the whole array. But we can also say it's O of 1 if we assume that only the pointers are copied. So that's why I kept these two options, O of n or O of 1. But just to give myself a boost, I would assume it's O of 1. But keep that in mind. And I was lucky enough because once I had click the submit button here, this is 100% faster than all the TypeScript submissions online. So I'm pretty lucky here. And again, as I always tell you, with Leetcode, every time you click the submit button, you always get a different result. But this time I will not click because I want to maintain that and feed my ego a bit. And yeah, that's it for that questions. I hope it was clear enough. Let me know what you think in the comments.